little bit of revision. I shouldn't really have to do this, but there were people that weren't in class this morning, so I'm not going to go over everything. In fact, you're going to have to find out from your colleagues some of the things that I said in today's lecture. We talked about universal beams and universal columns and steel channels, angles, and we talked about them in relative to the assignment. We also said how I want them called up in the assignment, and if they aren't called up that way, then you will be obviously losing marks. I then went on to talk about the different ways that we connect steel members, and indicated that bolting was the biggest one. And I went over the different types of bolts and how we position them when we dimension them. Now, all these things are very critical when it comes to assignment 3. Now, I don't know how many of you noticed, but assignment 3 is worth 40 marks. So if you've been doing fairly badly in the old civil department, then that 40 marks could mean the difference between passing or failing. For example, we've done 50% of the course. If you're sitting on, say, around about 20, 18, 17, you're going to need at least 30 in this last assignment to make sure that you pass. So not attending the lecture is not a good start. That means this round face here becomes part of your life next year as well, or next semester, okay? The ones that don't like that face, if you can put in a bigger effort, you won't have to see me next semester. But you might still end up seeing me in the project class. So, rolling on from that, we talked about the minimums and maximums for bolting, and I told you that that's going to be in the test, and I'll talk about that in the revision class as well. And I went on to tell you the type of well that is going to be needed in the assignment. So for those that weren't in this morning's lecture, you will need to correspond with other people in the class to figure out how to do the symbol for that on your drawings. So the other thing that I covered in the lecture was how to get started on your assignment. So there are two types of students with the structural assignment. There are the ones that go, oh yeah, I don't really understand that and I don't know how to start. And they're still doing that in about week 10, 11 or 12. And then there's the students that make an early start and suddenly find they have a few problems and they ask me or the past student and it gets them over that hurdle and suddenly they've just about finished their assignment. And I'd like you all to be that type of student if I can. So this year, I've given you a couple of examples from past year students. So in terms of the scheduling, today we're going to talk about scheduling steel, and your assignment is going to have, it won't have a beam or a column, but you will have what we call a rectangular member, a hollow rectangular steel member, which will make up our portal frame, and you will have an angle and you will have a plate. So special care on watching what I do now in my demo will mean that you can get yourself some marks in your assignment, and the demonstration I'm going to do for the class exercise is also in the test. 3 or 4 marks in the test. So for those that are hunting down some marks, there might even be the odd half mark question coming up Now, if you've already got a half a mark, tough, you won't get any more. If you I would love you to answer, by the way, because that means everyone else in the class won't like you very much. If you have it and you're hunting down a half mark and it only sounds like not much, think of the half marks that you lose when you can. It basically cancels them out, which means you're only being marked on the purity of your drawing. So let's get on with today's class, because we should finish within the hour, which will mean that you can have an hour to continue on with your assignment and the help of the class tutor and myself if it's too tricky for them. Okay. The other thing that I showed you is this in the lecture this morning. Now I'll explain this, how I would start my project. The first thing I've noticed is there's no dimensions on that, which is great. Don't put dimensions on here. This is not a dimensioned drawing. This is a reinforced concrete steel drawing. The second thing I noticed is that the student has left a gap around here, which is the cover. So they obviously did an offset for all these lines so that nothing went into the cover. So tip 1, draw a rectangle. I'm sure most of you can do that on, I really hope most of you can do that on CAD. Tip 2, offset for the footing and give it a line type that looks similar to that. Step 3, offset the cover all the way around. Step 4, have a think about it. This is not your assignment, this is a different one. These bars went along and down, and the blue ones went along and down, and this one here went along the bottom and came up. So at the end here, we have to do a donut. So it's sort of shaped where it goes along, curve, like that. It's got a curve at the end. So you've got donuts at the end of the light blue and the dark blue. You've got a lap, and I've shown you how to draw a lap, in that direction. Notice the smaller lap. There is a mistake on this because it says 36 here and it's lapping with 21 bars, but it doesn't matter when it comes to the, and 36 and 34, when it comes to the overall reinforcing schedule, on the schedule you're going to give, so for example if that was 36 and 34, that makes 70. So the number of bars would be 70 on your schedule, but you'd break them down for these where they overlap. Right? 36 and 24. In your case they'll be the same number because they're exactly the same bar. And remember how to do that? You divide the distance from where the bars start and end, etc. So this circle is 2 times the diameter of the bar that you've got the circle on. And you'll notice all of these fit very nicely in between the lines. And that's not easy to do. You may have to muck around with it a bit to get it to work. I don't want any of those lines overlapping anything. They can come down between here on these dashes, but not on any of the text. Alright? Very good example that. So that's going to be worth about 7 marks, that. And the reinforcing schedule is worth a very similar amount. So if you can get a handle on that, you're well and truly on the way. 14 marks towards 40 is quite a lot. And of course you should be able to do most of your quantities as well after today, except for the timber one. Right, so without further ado, we'll have a look at the class example. So can you all open this up on your computer screens? it's only showing one end of what we call a girder. A girder is a beam that's made up of multiple members. And where you might likely to find this, like I said to my class this morning, I think I did. If you've seen any of the Fast and Furious movies, about 8 of them, and you're into motor cars, then you would have seen the beams in the garages where they're fixing those pretty cool cars, and they had those things on chains that lifted the engine up so that they could fix it or swap it for a faster engine or whatever. It's quite common to see a girder type set up in a common garage, like the local garage here in Auckland, where you get your car repaired. And to strengthen the girder, often they have a second channel on top of the main beam going all the way, and at each end where you want to get some strength, they'll put something like a plate and a couple of angles, which will make a very solid girder. Now what I'm teaching you by all this is basically what's written up the top there, and how to schedule it, schedule that steel so that a steelie can see it and order off it, and so that you can price it to work out how much money that's going to cost the client. So in order to do this, and I'm not going to give you the answer, but I am going to open it. In order to do this, we have to draw up a table. So let's do that, eh? So we have the steel member called up here, the number off, so member, number off, that means how many there are, followed by the length, then the width, width, then the weight per metre, and finally the total weight of each member. And as a side thing over here, the thickness. Okay. So we're going to start with the member on the top, this one here, which is called a 381 by 102 by 55C, which is the old call-up, which you may well get in a test, and that translates to the new call-up, which is just a 381. TFC, a tapered flange channel. You can see that that's tapered a little bit. And it's a 55. So the number of them, there's just one on top. Easy. The length. Anybody tell me the length?
Is it 55?
No. 6 metres up the top. Well done, you've just got yourself half a mark, but you got a half a mark last week, right? Damn. Can you keep answering the answers? The width is not taken into account. The weight per metre. What's the weight per metre? The problem is all the good students have to shut up.
40.
See, he did almost work. How much? 40? No.
40.
1-4? No.
785.
Count down. You missed it.
7850.
7850.
No. Okay, so those that were in class this morning will know that the weight is the last number, which is 55. Okay? So the weight is 55. So when we multiply that by that by that, we get, for those that aren't holding up there, cell phones. Come on, you must be up to double task. No? I know 1 times 6, I can do that.
330.
330. Thank you. No, that's not half a mark. Making you work. The next one, 533 UB122. 533 UB122. That is the universal beam. Number of, that goes all the way through, that's 1. Just 1, right? And the length is 6 metres. Don't worry about the width. The weight per metre?
122.
122, correct. Equals
732.
732, right. Now it gets harder. The angle. The angle is 89 by 89 by 11 EA. But this morning I mentioned that you don't have to do the two 89s because it's an equal angle. It'll be 89 by 89, won't it? So it'll be 89 by 11 EA. So 89 times 11 EA. There is 2 of them there, and 2 at the other end makes 4. How long are they? For half a mile. Anyone? Where do they go from? They go from the inside of here to the upper side of there. Right? So if I draw the beam, the angle fits between here and here. Anyone tell me that height?
210.
It's 2 what?
210.
210. Wrong. Anyone else?
533.
533?
Yeah.
Closer. Like I used to say to my kids when they were looking for the hidden Easter egg, you're getting warmer. Not that there was any Easter egg there, but you're getting warmer. So I'll just tell you what these 2 students just told me. What did you say? 201 is that one. 533 is that one.
210.
Sorry?
210.
Was it 210?
511.7.
Not 90,
511.7.
511.7? No. I know how you got it, the answer's no. So, you're not gonna talk to me now? You can have another go. Anyone else wanna go?
329.
You're just yelling out random numbers.
483.
329, 483, that's getting closer. Don't say 484, who was.
411.
Okay, and the answer's at the top. For those that were in the lecture this morning, I talked about big T and little t. The big T and the little t, the little t is the flange, and the big T is the width of the web. So it's big T. So the answer is 533 minus 20 something. 20.
1.3.
We're talking about the beam. So it's 21.3. 2 times 21.3. So 21.3 minus 21.3 equals 490.4.
That's close enough for half a
20
mile.
20 or minus.
That. Which one's close enough?
483, close enough.
483 is close enough. Oh, no,
That's cute.
no, it's within 5%, and if you told Donald Trump he was with 5% with his tariffs, you'd be lined up and shot. Yeah, so that's how you work that out. So hold on, I'll stop working now. I've got to keep working. The length is now 0.4904. The reason for the 0 is in the end, our total weight is going to be in kilograms, and you have to convert it to meters. Okay, just like the steel. The width here is not relevant. The weight per metre, last half mark chance. Count you down, 10, 9, 8, 7, 6, 5, 4. Yep.
Do I get marks if I'm not from this class?
What class are you in?
Yes, sir.
You are too? No. You're sneaking into my class.
Yeah,
You're
because
supposed to,
Yeah, that's what
you'll get marks off because you're talking in the wrong class. He knows it's like, yeah, I know that, it's like you know the answer to the lottery, but yeah. Okay, it's up there written, somebody yelled it out before for another thing. It's 14 kilograms per metre. Alright, so the answer's 14. And so when we multiply, when my person with the calculator goes 4 times 0.4904 times 14, they get the answer of 27 point something, isn't it?
46. 27.46.
27.46, yeah. Okay. Now let me just tell you what you're going to have to do in the assignment. You're not going to be given that 14. I'm going to make you work for that. So in the assignment, I've already given you, as part of the assignment, the angle, and I've told you how long it is this way. Right? So I've told you that in the assignment, and I've given you this in CAD. So you need to draw if it's a P line right the way around, list it, and that'll give you the area. Let's call that X, the area times X equals cubic meters, doesn't it? And when you get your cubic meters, you need to use that 7850. Where's that disappeared to? 7850 is the weight of steel, and that'll give you the overall weight of it. So once you get the answer here, you multiply it by 7850. Now when you get the square metrics, you're going to get that in millimetres squared. You'll have to convert that to metres squared. That's not easy to do. And then you multiply it by that, that'll give you that number there. So that is something to take a photograph of for your assignment. Back on track. Last one. The plate at the bottom. So the plate at the bottom is 250 by 350 by 25. Don't make that mistake of putting those numbers here. What you need to put there is, we'll put the 250 by 350 by 25. The 25 is the thickness. There are two of them, one at each end. And what order do we put these in? The length and the width. It may not be what you think. In fact, it's the 0.35 first. So that's 0.35 and the 0.25 second. Now that is where I catch you all in the test. I have this blank and I have A there and B there, and I ask you to calculate A and you go 250, 0.25, easy, and move on to the next one. Whereas in actual fact, those numbers are reversed on this table. So if you can remember that and you get that as a question in the test, it is actually quite easy. And it's 0.35, not 350, because we're converting it to meters. So the weight per meter is 7850. So it's that times that times that, and now hold on. This is actually 0.025 times that. And the answer, which is on the big screen, is 34.34. And the total weight, don't forget to do that. A lot of students get a wee bit lazy in their assignment and they forget to put the total weight in. That will mean that they won't get the total marks. Is 1123.8 knots. 1123.8 knots. And just as a retaliation for that 483 being quite close to 490,
Should have given that shit, eh?
that bullet was real close on Donald Trump, wasn't it? But it wasn't good enough. No, it's all right. It depends. I mean, if you had to get to the nearest 100, you went too far off. The nearest 10.
Wiggle room to get in there?
Yeah,
Almost.
yeah. But then you've got a weld it. Should be fun. You're looking at a 5 or 6 mil weld. Okay, now this I'm going to make it available to you all. I just want to tell you one more thing before I log off here. With the with this one here that you can see where I'm blowing it up,
có gì còn
with the girder, we'll go back to the sketch of the girder. It depends how the mechanics put the I think it's called a chain and tackle on top of the girder. They normally have it so that they can free slide it all the way along. So they position it over the car or the truck and pull the motor out. So therefore, it would be very critical to calculate whether that's going to go over the edge. Because if it's going to go over the edge, it's going to interrupt the flow of the chain moving along. So we do a quick calculation. We know this is 89 by 89, but we don't know that width there, from there to there. So we need to do a quick calculation to figure that width out. And to do that, as you could see from what I was before,
tất cả là hiểu
I needed
tìm
to
ra
work
ra
out the overall width.
I don't know
And
người ta bạn
the overall width was 210 minus the x, which is 12.8, which is taken from that table at the top. We end up with 98.6, so there's plenty of room for the angles to fit inside. And that's just a bit of playing with steel, really, and scheduling it. But the reality is that steel's worth a lot of money per metre, per kilogram. So you really do have to get your calculations right. And the other thing is, when it arrives on site, you want it to be solid and fitting properly in place. And if you get your calculations, this is what I found, if I got my calcs wrong and the thing came to site, it was worth a lot of money to take it back and make it fit.
cô giáo calculate
So you had to be quite precise with steel work, including the holes and all that sort of carry on. So I'll make that available to everybody. I'm going to finish talking now. I said that you'd be well finished within the hour this week. A great opportunity to start your assignment. And I'll tell you this much for free. When the last few assignments from everybody else start piling in and you've got exams to swap for, you want to be well clear of my stuff, right? So the more you can do to get out of the road before you get onto the horrible stuff, the better. I'm going to be teaching you 3D in a couple of weeks, so that's going to be a little bit fun, unfortunately, and you are going to start doing that instead of your homework for other subjects, so it's best if you get on with getting rid of that, the harder stuff with this subject. There we are, the answers are there, you can study them, you can start getting on with your assignment. Our wonderful past student is here to help
Here is my assignment
and get you started on it. And I suggest you do your reinforcing schedule first
Ôi,
and move on from there.
ôi lấy cái thịt thịt.
number kहाँ है
Nó có series được.
100 क्या है
Food is